All right, here we go. We're broadcasting. Woo! Hooray! So today we're going to be running through logistic regression in R, something that I kind of barely understand, but we're going to work through it anyway. So starting off, attaching the data set, we have the library read Excel as usual. And instead of importing the data set like normal people would do, the easy way, we actually attach the data set as it is found in my computer machine.
No clicking?
Nope, no clicking. So we're going to attach the data set and we're going to rename the data set. And then we're going to rename the data set again to something even shorter because I like redundancy. So let's go ahead and run this entire thing. Boop. So for starters, in the assignment, we had to check correlations of the predictors, make sure that none of them were over 0.4. Pretty simple, just COR of the data, and then choose the series that you want and the three predictors that we chose. So as you can see down here, none of the predictors were correlated over 0.4. Over. So because you did it in your video, I'm going to do it in mine. I changed one predictor, locus of control, into the variable predictor, and then outcome was changed from burnout, or pushed into from burnout. Burnout is the dichotomous variable categorized as ones and zeros. Oops, that doesn't exist. So ones indicate that burnout occurs. Zero is that burnout does not occur. So that's our dichotomous variable. So for starters, we conducted a simple logistic regression, and we're going to push it into model 1. So GLM is the logistic regression. We have our outcome, then a tilde, then predictor. And the family binomial basically tells R what kind of regression we want to run. We want to use a logistic regression. So that's what the length equals logit is. So now that we have this model 1 of our logistic regression, we can start finding out information about it. So typing in summary model 1 gives us a couple of important details. So it gives us the significance of the predictor, the Wald statistics, all those fun values, the B, the standard error, the Wald statistic, and the significance of that. It also gives us the null deviance and the residual deviance, which are used, as well as the degrees of freedom associated with them, which are used to calculate the significance of the overall model. So just for the sake of typing it in and getting the individual numbers pulled out, even though they're right here, typed in model 1 deviance, null deviance, DF, null, DF residual, all that, and they pop up right below. So these numbers match the ones found up here from the summary. Next, we did chi-square degrees of freedom. So the model 1 degrees of freedom null versus residual, basically to see if the predictor is significantly different from the null in terms of degrees of freedom. And rows is the number of observations in our entire data set, which you could easily see as 1 plus the degrees of freedom, but that's just a different way to do it. And then chi-square V gives us the actual value of our chi-square, and that's found in a similar way that chi-square degrees of freedom is found. So model 1 null standard, or null deviance minus model 1 deviance. So using those, we use this little neat equation, chi-square P. No, sorry, P chi-square.
Wow. Right.
With the value and the degrees of freedom, subtract 1 from it to get the actual p-value. So that is our significance of the overall model. So that is found right down here, the chi-squared p. It's super duper low, indicating that our overall model is significant. Locus of control as a predictor does predict the odds that burnout occur. And now in order to find out what those odds are, we look at the odds ratio. So in order to calculate that, we get the expression coefficient of model 1, push that into the odds ratio, and then the confidence interval associated with that. Type in the confidence interval for that, and we get the OR and the CI, which I did not immediately use. And they're all the way at the bottom. It's the odds ratio for each of the predictors, but it basically tells us whether or not the overall, or it's the likelihood that burnout occurs over the likelihood that burnout does not occur. So just a list of all the variables that we created and used are down here. Each one of these we've made previously, and the ones that you have not seen the results for are the odds ratio ones. So our predictor 0.93 is less than 1, which means as the predictor increases, the likelihood of burnout occurring decreases. So that's pretty neat. As locus of control increases, likelihood of burnout occurring decreases. So useful information, and you get the confidence intervals around that. So moving on, we conducted a multiple linear regression. So this one has pretty much all the same things as the previous one, plus the other two predictors. But literally everything else is the same, besides obviously the numbers that get printed out from it. So just going over those, you'll see that the chi-squared degrees of freedom, rows 2, chi-square values 2, all those things we typed in again, and they will have different values than the previous model, but this model is still significant. So the p-value is 0, which is super duper weird. Never seen a p-value of exactly 0, but it's based off of it's based off of the degrees of freedom of the chi-squared being 3 and the value being 168.55 and the number of observations being 467. And moving on, the predictor, the odds ratio is 0.937. So it basically has the exact same odds ratio likelihood as the previous model, or very similar. As these three predictors increase, the likelihood of burnout occurring decrease because it's less than 1, and the confidence intervals are around it. Moving on, we are into the hierarchical. I'm pretty sure I spelled that wrong. Looks like there's missing some H's. Linear regression, hierarchical. Pretty sure there's another H in there somewhere. But we, the first model is with one predictor, and this is literally the exact same. Model 3 is the same as Model 1. All of the inputs and values are the same from that table. Same null deviance, same residual deviance. All that's the same significance of the overall model right there. Same odds ratio. So moving on, we want to see if adding coping styles adds an explanation above and beyond of the variance in the odds that burnout will occur. So we add coping and we see if this one actually changes. The degrees of freedom for Model 3 are different from the degrees of freedom for Model 4. So instead of calculating versus the null, we're calculating the delta chi-squared for degrees of freedom and the delta chi-squared for the value. So we get the change in degrees of freedom and the change in value to find the p-value for the significance of this new model to see if coping styles predict above and beyond what is predicted by locus of control. And we found that it is, in fact, a significant predictor by the Wald statistic, as well as the overall model is significant based on the increase chi-square value, or the significant chi-square right there. And so the last one, and the odds ratio is also in the same area, at 0.94. So this model is the almost same predictor as the previous 3 we've looked at. Moving on, the last step in the hierarchical linear regression is adding stress from research duties. The overall research was looking at the predictors of burnout for lecturers, so research duties would potentially be one. But looking at the summary for Model 5 and looking at the Wald statistic, it is not a significant predictor. Yeah, it's just terrible. So for this one, similar to Model 4, we looked at the degrees of freedom residual of the previous model versus Model 5. So the model that didn't have research and the model that does. We did the same thing for deviance to find the value of the chi-squared, or the delta chi-squared, and the p-value, so to see if the overall model is significant. And it was not significant. So the overall model was not significant.
Behind door number 2.
Behind door number 2 was a not significant model. That's what we have here. So we're not really worried about the odds ratio for this model, but we did calculate them. My video's not that long. It's probably long.
The readings.
Oh, yeah, the readings are long. So we do have 0.93 as the odds ratio predictor, which is kind of high, but the overall model is not significant, so we can't do much with that. And down here, the OR3, or CI3, that's the odds ratio for Model 3, confidence intervals for Model 3, Model 4, Model 4, Model 5, Model 5, and each one adds each of the additional predictors. And that's seen down here, so we can see if what the odds ratios are for the individual predictors inside each of the models. So right here is for odds ratio for Model 3. Down here we have predictor and the second predictor for Model 4, as well as their confidence intervals down here. And then for Model 5, we have all 3 predictors and all 3 confidence intervals surrounding them. I think that's everything. So we're going to end the video now.
Yeah.
Everybody say bye.
Bye.
Vinay, you didn't say bye.
Bye.
He said bye.